Look, guys, here, in 2015 math test was problem 18. So let n be a positive integer. When the leftmost digit of the standard base 10 representation of n is shifted to the rightmost position, the units position, the result is n over 3. Find the smallest possible value of the sum of digits of n. So let n have d digits. Then let's say the first digit of n is x, and the string of d minus 1 digits after that is y. So then we have that 10 to the d minus 1 times x plus y is equal to 3 times 10y plus x. So simplifying, we get 29y is equal to 10 to the d minus 1 over 3. And so now let's just divide the 29. So we have y is equal to this, right? And since y and x are both integers, we know that 10 to the d minus 1 is equal to 3 mod 29. And so this means that multiplying 10 on both sides, 10 to the d is equal to 1 mod 29, because 30 is 1 mod 29. And we know that by Fermat's little theorem, this would be d is 28. But we want to make sure that 28 is the smallest d. When d equals 1, and also we only have to test divisors of 28. So when d equals 1, 10 is obviously not equal to 1 mod 29. It's equal to 10 mod 29. I'm just shortening with parentheses 29. 10 squared is equal to 100, and we know that 87 is a multiple of 29, so 1329. 10 to the 4th, we can just square 13. We get 169. 169 is 24 mod 29. 10 to the 7th, we can multiply all three of these together. We got 240 times 13 is equal to 17 mod 29. And lastly, we can just square this. 289. 289 is, obviously, 289 is 1 less than 290. So 10 to the 14 is equal to negative 1 mod 29. So we know that 10 to the d equals 28 is the smallest. So now we know that n is equal to 3x times 10 to the 28 minus 1 over 29. We want to find the sum of the digits of this. So we can simplify into 3x times 10 to the 14 minus 1 all over 29 times 10 to the 14 plus 1. Or no, let's switch it around. Since 10 to the 14 is negative 1 mod 29, we know that this is always divisible by 29, and we'll have 14 digits. Here, we know that any number, for example, 1, 2, 3, this is just going to be 9. It's going to be 14 nines. So we know that any number times 999. What is 1, 2, 3 times 999? It's 1, 2, 3 times 1000 minus 1, 2, 3. And so that would be 1, 2, 3. It would be 1, 2, 2, and then think about it. It would be 1, 2, 3 thousand minus 1, 2, 3. What is this? This is 7. 877 122 877. And would you look at that? Would you look at that? 2 plus 7 equals 9. 2 plus 7 equals 9. 1 plus 8 is equal to 9. So these digits should all sum to 9. Each pair of digits should sum to 9. So the sum of this should just equal 14 times 9, or 126. And so, well, if d is greater than 28, then obviously the sum will scale as accordingly. So 126 is going to be our answer. Thank you guys for watching.